Thank you for joining us today. I'm super excited to be here and welcome everyone to the official start of the new series, We Are Women in Economics. For those of you who are joining us for the first time, this is a seminar series aiming to bring together junior and senior women in economics to contribute to building an active and cooperative CEPR women in the economics community. My name is Juanita Gonzalez Uribe, and I'm at the London School of Economics. And today we have a couple of great presenters. Anna Rogantini will be the host, and Melissa Prado will present her most recent work on socially responsible investment with some very cool data, as we just discussed a while ago. I also wanted to tell everyone that the We Are seminar series are now going to be structured around thematic weeks each month, and they're designed to facilitate deeper and more impactful conversations. And the first week every month will be devoted to finance. And so if you like what you see today, which I'm sure you will, the next one will come up on November 4th. And then we'll have, I think, November 25th, according to our schedule. But anyway, without further ado, I pass on the baton to Anna, who's our host today.
Thank you very much. I'm very happy to be the host of today's seminar. We have a great speaker who's Melissa Porras Prado. She's a full professor of finance at Nova in Portugal and a CPR associate as well. She has amazing publications in finance, like Journal of Finance, JFE, RFS, and you will see that also today's work is going to be great. I'm very excited to hear about it. The title is Socially Responsible Investing and Multinationals Pollution, Evidence from Global Remote Sensing Data. I think it's a very original and innovative, but then Melissa will tell us more about it. So we have an hour in total. Melissa will present for about 40 minutes, and then we have a Q&A of 20 minutes. We can interrupt for questions because Melissa said she's happy with it. Maybe more like clarifying questions during the talk, and then we have time for more content-wise questions later on. So I think if Melissa wants to start sharing the slides, and then we can get going.
Yeah. Can you see it?
Yes, perfect.
Perfect.
I forgot to say that people can also write in the chat if they want, but I think it's also nice to ask questions in person. But we'll see. Okay, so Melissa, you can get started. Thanks a lot.
Thank you. Thanks, Anna. Thank you all for being here, and thank you for allowing me to present this very preliminary work. So that will definitely benefit from any comments or suggestions that you guys might have. And I'm also very proud to be part of this Women in Economics seminar series. So as was introduced, this paper is Socially Responsible Investing and Multinational Pollution, Evidence from Global Remote Sensing Data. It's joint work with Virginia Giannazzi, Victoire Gerard, who's also here present as well, and Mehdi Leilali. All of us are at Nova School of Business and Economics. Let me see. Okay. So social responsible investing is on the rise. A lot of institutional investors are committing to invest sustainably through initiatives like the PRI, the Principles of Responsible Investing. So for example, as you see from this graph, in 2006, around 63 institutional investors signed that they were going to invest according to these principles. By 2021, that represents around 4,000 that year. And in total, in terms of assets under management, that's 121 trillion US dollars in assets under management that supposedly is invested according to social responsible guidelines. Now, given this influx of capital, it becomes a pertinent question as to how effective that is in changing firm behavior in terms of their environmental practices. So that's effectively what we try to do, is to see what are the real effects of social responsible capital. And effectively, what we know thus far is US-based. So it's an important question. So obviously, many have come already before us. But they, to answer that question, they've always had to rely on US data, because obviously that's where there's much more monitoring and publishing of this pollution data. However, we also know that multinationals have the ability to displace their pollution to, for example, poorer countries and facilities that they might have there. So that's why, to answer that question, we need to look at it on a global scale and really see whether social responsible investment reduces the pollution of a multinational across all of their production networks globally. Now, the problem with answering this question globally is obviously the lack of data, particularly in poorer countries where there's less monitoring and recording of this. It is increasingly becoming more available, for example, when you think about CO2 emissions. However, much of that is still self-reported. It's either at the country or firm level, then it might be estimated, and is also subject to manipulation. So there's this paper by Zhu that shows that even local municipalities are very strategic when it comes to monitoring days of air pollution stations. So you can imagine that that sort of also extends to firms. And therefore, what we actually do is we use satellite remote sensing techniques to measure the relation between pollution and vegetation health. So we're going to be looking at facilities and the vegetation surrounding these facilities and seeing whether over time, as these are owned by socially responsible investors, there's an improvement in the vegetation health, which would suggest that they're polluting less. So that will be the way in which we're going to sort of monitor firms' ecological footprint. Now, we sort of center this in, obviously, environmental sciences literature, so that showcases that vegetation responds to pollution. But additionally, because we're doing this on a much larger scale than what has been done before, we also validate this with two sets of tests. So we look at sort of country, again, US, where data is available on toxic releases, and correlate that with vegetation health. And that acts as our first validation test. Then we look at how vegetation responds to industrial accidents. So when there's sort of immediate stress, and we see indeed that vegetation declines. So this is, again, encouraging as to allowing us to monitor over time how these firms are polluting. Then what we do is we analyze the world in 0 by 1 degree grid cells around these multinational industrial facilities. And then we measure the average vegetation health in these grids and correlate that with social responsible ownership. For proxy of social responsible ownership, we're going to be using the signatories of the PRI, but you can also have other measures of social responsible investing through, for example, looking at their holdings data and ESG data, which in the presentation I won't get to, but it's robust to using that as well. Then when we establish that correlation with social responsible ownership, we also look at whether there's a difference in facilities located in richer versus poorer countries, so OECD and non-OECD facilities. Okay. So that's a bit of the roadmap. First, let me talk you sort of through what the contribution of the paper is. So it adds to this very large and important literature on the real effects of sustainable investing, be it through the cost of capital and engagement. In particular, we're going to sort of focus on the role of social responsible investing in displacing pollution. So there's been papers have shown that firms have this ability to displace pollution. For example, this Tanaka paper Tanaka et al. Is very interesting, in which they show that in response to regulation, the Clean Air Act, battery recycling was moved from the US to Mexico. So what we're going to be doing is looking at how that whether that is attenuated with social responsible institutional ownership. So the advantage that we have with respect to other papers is that we have very granular data. And obviously, by looking at vegetation health, we're going to be able to do this globally in an unbiased way. We don't have to rely on firms reporting or measurement of pollution, it's at a high frequency, so it's every 2 weeks measured, and it's also very importantly multispectral. And this is very important because there's this paper by Gibson that shows, also in response to the Clean Air Act, that firms substitute in their production polluting air, obviously to mitigate, to comply with regulation, with polluting more in water. Okay, so the advantage of using vegetation, looking at vegetation health, is that vegetation responds to air, soil, and water pollution. So that allows for of a more holistic overview of the impact that a firm has in terms of its pollution activity. Also speaks to the literature that goes beyond emissions. This is not to say that emissions obviously are not important. CO2 and to tackle global warming is a very first order thing. But again, with this possibility of pollution substitution, it becomes important to not look just at one particular source of pollution, but examine really the broader environmental impacts. And lastly, we contribute by using sort of satellite data and remote sensing techniques and enabling sort of the monitoring through these techniques and hopefully supporting regulatory reporting and informing sustainable investing. So what I'm going to sort of take the next 35 minutes or so, 30 minutes for this presentation is, first I'm going to talk to you about what is this measure of vegetation health. So that's the Normalized Different Vegetation Index, NDVI. I'll explain what that is. Then I'll take you through the 2 validation tests that we have to hopefully convince you that the NDVI is a good way of monitoring firms' overall pollution. Then we're going to actually answer our main research question, which is the impact of social responsible capital, and examine the heterogeneous effects across OECD and non-OECD countries. So the measure of vegetation health that we're using is the Normalized Difference Vegetation Index, NDVI in short. So it's a standard metric for vegetation health, so often used to measure crop health and productivity, or for example, deforestation. It ranges between -1 and 1. And sort of -1 would be where it sort of reflects the infrared light very well. So think about this as snow and water. And to the higher end, you would have healthy vegetation. Sort of think about the Amazon forest being the closest to 1. Then if you have rocks or buildings or barren areas, that would be indicated with a value close to 0. Okay. Now, how does it work? How do how does this index come about? So what you see here in this picture is sort of in this panel that I highlight over here, the green panel on the left, you see healthy vegetation. Now, healthy vegetation has a strong leaf structure and is very green. Okay, in the process of photosynthesis, it produces chlorophyll, which absorbs red light. So what this NDVI does is it basically emits visible red and near infrared light. And when you have healthy vegetation, what will happen is healthy vegetation absorbs a lot of the visible red, which it uses for the chlorophyll production, and expels or reflects a lot of the near infrared. When you have unhealthy vegetation, which is what you see here on this right half, you see that it's not as green, and what it actually does is the opposite, right? So it expels more visible red, and it absorbs more of the near infrared. So the NDVI is the difference between the near infrared light and the red light over the sum of the 2. Okay, so again, closer to 1 would mean healthy vegetation, strong vegetation. So think of a forest. Grass would be around 0.2 to 0.4. Okay, also depending on when you're measuring this, in which season you are, of course. And again, -1 would be reflectant of snow. So this is how it looks over the course of a year. Okay, so you see it changing colors. When there's snow, it would be in the red range, -1, and a strong green that you would, for example, observe here in the Amazon region is when you have the healthiest vegetation. Okay, so as you see, this also changes a lot over time, and we're going to be having to deal with that as well in our specifications. Now, disclaimer, the NDVI is not a direct measure of the level of pollution. So what we're using it for is to look at changes in local pollution and using it as a way to monitor firms' pollution activities. Now here, the key is that we're focusing on local pollution. So that obviously is important to highlight. And even if you think about air pollution, which is the pollution that travels the most, if you will, it's less local, even that it has strong local effects. So there's this paper by Curry that shows that it affects the air quality and health within already 1 mile of the plant radius. Okay, so local pollution is what we'll be able to monitor. And then, as I mentioned before, it's multifaceted. So we're going to be looking at so the NDVI responds to different types of pollution. So in the environmental sciences that I highlight here, one of some key papers, there's evidence that it correlates with air pollution, CO2. It's negatively related to soil contamination, particularly heavy metals, decreased NDVI values, and also negatively affected by industrial activities and that contribute to water pollution because it affects the nutrient intake of the vegetation. So that sort of frames the use of the NDVI, but since these studies have not done this on a very large scale as we're doing across the globe, so we also wanted to validate whether we could use the NDVI and vegetation health as a way to monitor pollution. So to do that, our first test centers on using data from the US Environmental Protection Agency, the Total Toxic Release Inventory Program. And that tracks from industrial facilities, all the toxic chemicals that are harmful to health and the environment. So all toxic facilities that have a specific size, so they need to be 10 employees in specific sectors that use specific chemicals and specific sort of low thresholds of this, they need to report to the TRI. So this is self-reported data from these industrial and federal facilities, and we're going to be using that from sort of our sample period 2006 to 2020. And we have both public and private facilities, around 36,276 to be exact. And we're going to use those facilities to sort of geo-coordinate and map it with the TRI total releases, and then correlate it with the vegetation health, the NDVI surrounding these facilities. Now, important to note is that most of the toxic releases are on site. Again, what we're looking at is local pollution at 70% versus 30% are off-site. And this we're going to also use as a sort of a placebo, if you will, to see that we should not be able to measure off-site pollution with our NDVI. Now, this is how the NDVI would look like, for example, in Houston. So this here is a map of Houston in which all the black dots are industrial facilities. And what we're going to be doing is basically measuring in this small quadrant that you see highlighted over here, the average vegetation health, okay? And then sort of measuring whether those that have more toxic releases indeed see a deterioration of the vegetation health. Now, the size of these cells is 0.1 degree by 0.1 degree. That's approximately 11 kilometers by 11 kilometers. The control variables on weather will be coming from a bigger cell. So that's the bigger quadrant highlighted over here. That's approximately 55 kilometers by 55 kilometers. Now, what you also see is that some of these cells, they're very clustered. So there might be many facilities at the same time in the cell. So sort of to be more direct in terms of attributing, if you will, to that particular facility, we also do subsample analysis in which we're focusing on cells in which we know there's only one facility in place, okay? And results go through, and I'll show you in the following slides. So as I mentioned before, what we're going to be doing is we're going to be regressing the NDVI, the average NDVI in a cell at that sort of yearly frequency onto the reported total releases in the cell. So it's the sum of all the toxic releases in that particular cell, and then controlling for weather, which is obviously our important control, so rain and temperature, and also their squared counterparts, because it's sort of a non-linear effect. So rain is good, but too much will be bad, for example. And then we also control for cell characteristics. So we're going to be introducing as controls light emissions, sort of as to control for economic activity, nighttime light, buildings, and populations.
Melissa, one second. I think we catch a question.
Do you mind if I interrupt you with a question about
Go ahead.
your index measure, just to understand better as I go on? So the index, I was thinking about intensive extensive margin. Your index measure captures the health of the existing vegetation.
Exactly.
But if in a given area, there is a company that comes in and it's an agricultural company or any other business, and they do some deforestation. So the amount of vegetation of you know, the square, the area that is covered by vegetation changes.
Exactly.
Will that change your index, or, you know, how
It
do you deal
would.
with these differences?
It would.
Someone, you know, a company establishes some monoculture, some intensive farming, and they cut all the trees. I was just curious about how the index is capturing these different dimensions.
It would indeed. So it would indeed reduce the NDVI value. So that's why it's going to be very important to introduce controls for this. And this is what these cell characteristics try to hint at. So for production differences, for example, would be captured by nighttime lights, buildings, changes in buildings that will be measured every 5 years, and population density will help also in terms of trying to sort of mitigate that it's just some process of industrialization, for example, that is happening, or as you described, sort of any changes that could be in that direction. Additionally, it's going to be very important to have high dimensional fixed effects. So we're going to be introducing cell by month fixed effects and year by month fixed effects, again, for seasonal changes that might happen. And we're going to be introducing also agroclimatic zones by year fixed effects to account for differences across agroclimatic zones, which would be sort of some of the differences that could happen as well.
Yeah, thank you.
Okay, so that hopefully that's clear as to what we do. So the first thing of this validation test is to regress the NDVI on total releases. That's what you see in the following table. So in this first specification, we use the yearly frequency, and as the NDVI is available on a bi-weekly basis, every 16 days, it's recorded to be exact. We also have sort of in the second specification using the bi-weekly frequency. You see that across here, this is with even more stringent fixed effects. So when we, for example, in the third specification, start to introduce year by agroclimatic zones, and you see that across all these three specifications, the results are statistically significant. So more total releases, a 1 standard deviation increase in total releases reduces the NDVI by 0.02 units. Okay, so there's a negative and statistically significant relationship. Then we do the split in terms of on-site versus off-site. And again, here, this acts a bit as a placebo test in which you want to see that the NDVI only responds to local on-site releases. Things that are shipped away or sort of put off-site would not be able to capture with the NDVI. And that's what you effectively see in the fourth specification, that it's all concentrated in the on-site releases. Now, since we're also interested in capturing improvements, not just deteriorations of pollution, we did a subsample in the 5th column in which we're looking at when there is an improvement in TRI. So when in the past year, there's been less reduction of toxic releases, and you see the same symmetric relationship there. And lastly, we look at cells in which we can pinpoint it more directly to that particular facility by looking at cells where there is just one plant. Now, in terms of what these numbers represent, so we sort of have, in terms of economic magnitudes, it's around a reduction of 8.13 tons of toxic releases. Since that might not say much to you, it didn't say much to me initially. So that corresponds to more or less what on an annual basis 1.7 cars would produce in terms of CO2 emissions. Or if you want, in terms of what the average home in terms of electricity consumes, it corresponds to around 9 months of that. So that's the first test, which already reassures us that, you know, you can capture sort of toxic releases of industrial facilities by looking at the vegetation health. But we also wanted to see whether sort of the vegetation health responds to acute stress. So, for example, during toxic chemical spills. So here, what you see in this map, the map of the US, where we have data on US Coast Guard's reporting of toxic spills over the sample period 2006-2022. Here we see all these dots, the blue ones and the red ones are toxic incidents that happened. And what we're going to be looking at is the top decile of incidents. Those are the red dots, so the more severe incidents. And that corresponds to around 210 evacuations in terms of people that were displaced for those incidents. And those will be 351 events. And what we're going to be looking at whether the NDVI sort of responds to this acute stress, and also it allows you to see how long it recovers. So we follow this paper by Tian that also uses the same, although they are more restrictive in terms of the number of incidents that they use. And basically what we do is we look at 7 months prior to the incident and 7 months after, and see whether the NDVI is abnormally low. So whether it's really sort of indicating stress. So this is a de-seasonalized NDVI variable that we're using as our dependent variable, so as to see whether the NDVI is going to be abnormally low. As a control group, what we're going to be having is the neighboring cells as spaced from the closest neighbor of 0.1 degree to all the way up to 1 degree cells. Okay. And this is basically how it would look like. So here you see all of the neighbors. So cell 0, this row corresponds to the cell in which there was this toxic spill. And then we're moving basically 0.1 degrees, so 11 kilometers, and 2 times 11 kilometers, et cetera, until we sort of move away more geographically from the scene of the crime, if you will. So at time 0 is when it happens, when the toxic spill occurs. That is the month around the toxic spill. And as you see here at the actual location, there's a strong and negative impact on the vegetation health. And what is very cool, at least I think it's very nice to see, is that it's also monotonically decreasing in magnitude as you move away to further geographically more dispersed cells. Okay, so the effects are obviously strongest in the cell in which the accident happens and the vicinity of the cell. You also see that the effect sort of lingers in the neighboring cell all the way up until 4 months, if you will, after. You still see some negative and statistically significant coefficients. So it lasts for a while, and then it seems to at some point be indistinguishable from 0, 5, 6 months after the actual incident.
Lisa, can I ask you a question?
Sure.
I think that the reason why you're doing this validation exercises is because you would want, I think, to show that your new measure is related to other measures that we're more familiar with, you know. But it seems to me that what's really cool about your data is that you can potentially pick up stuff that the pollution measure and these other measure cannot. And so I wonder whether you've done kind of like the reverse exercise in some sense of showing us which are the firms that, according to your measure, would seem to be doing some damage, but that you cannot really pick up with the other measures that have been used in the literature. So that rather than validating, you kind of like, you know, really empower this NVDI thing that NDVI measure that you've come up with. I don't know if you've done that.
Yeah, we found we thought about doing this, and we found that the NDVI is very noisy, right? So it's not easy to just from looking at NDVI values determine that there was, for example, especially at this scale, that there was for some environmental incident. So there is a bit of a limit to how much you can stretch this. That being said, it would be an interesting exercise to think about how we could we haven't been able to do that in a proper way, but we're what we thought about, okay, once you know when there is an incident, it's easy to figure that out and see it in the data and collaborate that the vegetation is deteriorating. The other way around is given, obviously, there's different agroclimatic zones, there's different vegetation types, all of that becomes very complicated to pinpoint and target. Okay. So hopefully I've convinced you guys that you can use the NDVI to monitor pollution in that it correlates with chronic cumulative pollution impact, as toxic releases would suggest, that the effect is concentrated on site, and that it also correlates with acute stress. So when you see toxic chemical spills, we can observe that in the data. Now that I've hopefully convinced you guys that this is a way to monitor pollution activity, we're going to try to address our main research question. What's the effect of social responsible ownership on the pollution activities of firms? So for that, first off, we get all of the location and addresses of international establishment of US industrial multinationals. So here we're going to focus on SIC code 1 to 39. Reason being, these are the industries that contribute the most. These are the brown industries, if you will, to emissions and all types of pollutions. So that's why we wanted to focus on that. We get the data from Dun & Bradstreet. That's a static snapshot of the plants. Okay, so and also it's all about within firm borders. So everything that it gets displaced outside of the firm, we would not be able to capture. And if there's changes in plants, we wouldn't be able to observe that in our data snapshot that we have. So that's a caveat to take with. Then we take and match the data with Compustat to get and the FactSet ownership to get time varying institutional ownership. We identify those firms that are held by socially responsible institutions as those that have signed the PRI, and which amounts to around 5,376 institutions. And then our measure of social responsible ownership is the fraction of the ownership that is held by these signatories. This is how our data looks like geographically. All of these dots are these facilities. We have 911 industrial multinationals in total, which have 42,806 facilities. 4,353 of those are located in non-OECD countries, and the rest is located in the OECD countries. The average multinational has 58 facilities, the median 18, and more than half, 493 out of the 911 multinationals that we have at least one facility in non-OECD countries. These are, just to mention, these firms that have at least a facility in non-OECD countries would be what we call also the global firms, the global multinationals that have presence not just in OECD countries, but also in non-OECD. And in our analysis, we're going to look at those separate as well. So what we're going to be doing is we're going to be, again, regressing the average vegetation health in a cell onto the institutional ownership of the cell that is socially responsible. Here, what we're going to be using is a rolling window of social responsible investment over the past 4 quarters, mainly just we played a bit around with that with the past quarter. It works as well. All the way up until 3 years, then it sort of reduces, but sort of to have an indicator of stable ownership. We used and the time frame to react to that ownership. We used a rolling window of 4 quarters. We control for institutional ownership, and also obviously for the weather and cell characteristics that I mentioned previously. Again, the same set of controls. We introduce cell month fixed effect, agroclimatic by year fixed effects, and to account for seasonal changes, the year month fixed effects. Okay, so here is the regression result for the full sample that we have. Those cells in which there is socially responsible institutional ownership, we see a positive and significant relation with the NDVI. So there is more sort of healthier, if you will, vegetation in those cells. Okay, and again, this is consistent across having high dimensional fixed effects, where, for example, controlling for year country or agroclimatic zones. It's robust again also to introducing institutional ownership as a control variable. And when we're looking at particularly cells in which there is one sort of plant, so as to more directly tie it to that particular facility, we see that the magnitude of that coefficient doesn't change much. Okay, so this would be the subsample of facilities that are in of cells in which there's only one facility. Then we look at global firms. So these are these firms that have the ability to displace their pollution to facilities in poorer countries because they have these facilities in the first place. And there we see also for global firms, higher level of social responsible ownership is positively correlated with better vegetation health, which would be suggestive of a reduction in pollution activity. Then we looked at the heterogeneous effects, and here what you see is very interestingly still the same positive and statistically significant coefficient on CRI ownership. However, if you interact that with a dummy variable that is outside facilities outside of the OECD, you see there that it's strongly negative and statistically significant. So this suggests that social responsible institutional ownership is indeed improving the vegetation quality and thus polluting less in OECD countries, but not so much in poorer countries where there's obviously less monitoring and less reporting happening and less visibility in general in these poorer countries. To give you a sense of the magnitudes of these effects, so a 1 standard deviation increase in social responsible ownership increases the NDVI by 0.038, which is the equivalent of reducing toxic releases by 154 tons. Now, if you still don't know how much that is, that's equivalent to, for example, the emissions of around 34 cars or around 14 years of electricity use of an average US home. Now, for non-OECD, however, what you see is that it deteriorates the NDVI, and which would be suggesting that all of these benefits would be are undone, and that the pollution is actually being displaced from facilities in the richer countries to facilities in the poorer countries. And again, here in terms of controls, we have already controlled for nighttime lights, which is for economic activity. We control for number of buildings and population. So none of those could be explaining the difference in how much this social responsible investing is influencing outside of the OECD.
Can I jump in before you conclude? I was thinking whether there are changes in regulation over that you're looking at that you could exploit and see whether, for example, multinationals displace more when regulation becomes more stringent in a country, and then they move their pollution to less regulated ones.
Yes, we haven't explored that as much. We've looked at sort of the cross-sectional differences in lenient laws versus laws in which they're less environmentally friendly. But we need to pinpoint exactly what would be the regulation, and ideally, and indeed non-OECD countries, and see whether that we can observe that in the data a differential reaction. So that we haven't done yet, but I think it's an interesting exercise to explore for sure. Okay, so the objective of the study thus far was to look at the real effects of social responsible investing and capital on environmental behavior of multinationals, particularly industrial multinationals, across their entire production network. We utilize the NDVI as a way to monitor vegetation health, so as to basically make visible the invisible, particularly in poor and non-developed countries, poorer countries, as an indicator of the environmental footprint of a firm. First step, it was to validate that there is a correlation between NDVI and pollution, so as to be able to use it as a measure to monitor firms. And what we did is we established a correlation between NDVI and the toxic releases in the US. We see that indeed more releases of toxins correspond to a deterioration of vegetation health. Then we also looked at acute stress and found that moments of which there are incidents, toxic chemical or industrial accidents, we see that the NDVI reacts, it deteriorates considerably and lasts up to 4 months before it is indistinguishable from zero, the reaction, and starts to recover. So once we've validated our measure, we find a positive correlation between social responsible investing and NDVI. So in cells in which there's more social responsible ownership of the facilities and the parent company, the vegetation health seems to be improving. So that is indicative of better environmental outcomes. But this is, again, concentrated in OECD countries. Outside of the OECD, we see the vegetation quality deteriorating, which is suggestive of firms displacing their pollution to these facilities. Now, thus far, we have this is a preliminary and first draft of this work. So we have a lot of things that we want to explore a bit further. We want to sort of pinpoint that relation with institutional ownership a bit better by using salient wildfires at the investor level to see whether when their investors are shocked by sort of environmental disasters or sort of face this smoke exposure, whether those are indeed more likely to improve at their facilities, so put pressure on these companies to improve their environmental practices. Then additionally, we want to look more into the engagement channel. So following PRI means 6 principles that the firm has to, and the institutional investor has to document in terms of what they're doing and to make their portfolio holdings more sustainable and environmentally friendly. So we want to use that data to see whether there's differences in this type of engagement. And then we want to explore a little bit more the heterogeneity, as was already suggested, maybe look at different sort of regulation, but also look at whether there is a pecking order, if you will, in terms of where the pollution would be first sort of displaced to, for example, to population less dense areas would be one of the first things we can explore in that pollution allocation choice. A lot of things to still do, but hopefully you found this interesting and have seen that using remote sensing, you can make visible what has been invisible thus far.
Perfect. Thank you.